So we're going to talk a little bit today about dealing with 3 dimensions. Now, kids, here is the good news. With the just 2 exceptions, everything we do today is going to be done exactly the same way it was done in 2 dimensions. So, this means find the distance from A to B. Find the distance from A to B. Who remembers the distance formula? Square root?
Square root x1 plus x2.
Not plus. Minus. So we subtract the x's, subtract the y's, square those, add them up, and take the square root, right? That's the distance formula. So guess what? In 3 dimensions, we do exactly the same thing, only instead of just having x's and y's, now we also have z's. So we'll take the square root of 1 minus negative 2 squared. Everybody with me? Plus 2 minus negative 5 squared. Plus 3 minus 1 squared. And then we just do the work. So 1 minus negative 2 would be
3
squared,
9
2 minus negative 5
7
squared, 49, and that would be 4. So we end up with what? The square root of 62. There's your answer. Easy? Midpoint, same thing. How do we find the midpoint in 2 dimensions? Add them and divide by 2. We average. Well, guess what? We're going to do the same thing, only instead of just having x's and y's, now we also have z's. So the midpoint will be 1 plus negative 2 divided by 2. So negative 1/2 for my first coordinate. Remember, we're averaging. Add the x's, divide by 2. Now, add the y's and divide by 2. And add the z's and divide by 2. Everybody okay with that? Nothing new or different. Parametric equations of line AB. Whoa, back up. Parametric equations. Does anybody remember how we start this? Remember, we write a vector equation first. This time it'll be x, y, z equals a parentheses plus t times the parentheses. Do you remember that? Oh boy, we need to remember that. Anybody who does remember what goes in this first parentheses?
No. 1, 2, 3.
One of the points. Doesn't matter which one. One of the points. So it's a 1, 2, 3 right here.
It's a T.
This is a T. Remember, that's your parameter. Now, what goes in that second one? The vector from A to B. So if we're at A and we're going to B, we're going from 1 to negative 2. What is that?
Negative 1.
Okay, kids? How many steps is it from 1 to negative 2? Negative 3 steps. From 2 to negative 5, negative 7 steps. And from 3 to 1, negative 2 steps. Now, this is not the parametric equations. Do you remember how then to get the actual parametric equations? We split this up, right? Do you remember how to split it up? We take all the first parts. So what would that x equation be? X equals 1 minus 3t. I'll write them up here. What will y equal? 2 minus 7t. And now we got a z component also. So z will equal 3 minus 2t. Okay, so just a quick backup on that. To write the parametric equations of the line, we have to start by writing the vector equation. So that's x, y, z equals parentheses plus t times parentheses, right? What goes in this first parentheses?
One of the points.
One of the points. What goes in the second parentheses?
Difference, or
The vector from A to B. All right, speaking of vectors, I got another set of problems here. 3-dimensional vectors. We're going to add them together, find the resultant. We're going to add them together. Take a wild guess and you'll be right. What will the sum be? Add these two together. What are we going to get? 1, 2, 2. That's it. How do we add vectors together in 3 dimensions? Same way we do it in 2. Add the x's, add the y's, add the z's. See, right? You okay with that? Pretty easy, right? How about this? What's 2v? 2v will simply be 2, negative 2, 8. Bingo. What do we call 2, by the way? Little review. 2 is called a scalar, yeah? Now this is a dot right here. V dot u, the dot product. How do we find a dot product? Do you remember? You people are way too young to have Alzheimer's. Come on now. How do we do a dot product? Multiply x times x, y times y, and add them together. Now, we're going to do the same thing, only we're going to take x times x, y times y, z times z, and add them together. So what's my dot product going to be? X times x will be 0, y times y will be negative 3, and z times z will be negative 8, so your dot product is negative 11. Okie dokie smokies. This is brand new. This is the cross product. And you can't do a cross product in 2 dimensions. That's why we didn't do it. You have to be 3-dimensional. So this is going to be a new process. So everybody okay with this? I'm going to erase this. Cross product has a lot of pretty cool uses, but before we talk about that, we need to figure out how to do it. So I'm going to go ahead and cross these 2 vectors, and I find it easier when I do the cross product to write the vectors vertically. Some people write their vectors vertically all the time. I don't do that, but I think it is easier to do the cross product. First big difference. Remember when we did the dot product and I just erased it, but we got a number, right? We got a single number, negative 11. When we do the cross product, we're going to get another vector. So I have 3 numbers I have to find. Okay? Real easy. To find the top number, cover up the top 2 numbers. And what you have left, these 4 numbers, we're going to find the determinant value. And what that means is we're going to take negative 1 times negative 2, 4 times 3, and subtract those. So we're going to take negative 1 times negative 2 and subtract 4 times 3. So what do I get? 2 minus 12, I get negative 10, and that's what goes on the top. So let me go through that again with you. To find the top number, we cover up the top numbers. We do this times this minus this times this. 2 minus 12. Everybody got it? Now guess how we find the middle number? We do the same thing, only we cover up the middle numbers. So that would give us negative 2 minus 0. But here comes the tricky part that you can't forget. When you do that operation, this times this minus this times this, for the middle number only, the sign changes. So instead of getting negative 2 minus 0, which is negative 2, it's positive 2. That actually is a very common theme in the study of matrices, which we haven't had yet. But that sign change happens a lot. Okay, and then on the bottom, here we go. 3 minus 0, I got 3 on the bottom. How about you? Did you? All right, let's have you practice another cross product since you've never done that before. It's easy, but let's just have you practice one more to make sure you've got it. And then I want to show you something that's really pretty amazing. Let's cross 1, 2, 3, and negative 2, 1, 4. Can you find that cross product? You get 5, negative 10, 5? Anybody have a question about any of those numbers right here? Okay, now here's the sidelight, the really cool thing I'm going to show you. There's the cross product vector that I just got. Here are the 2 original vectors. I'm going to find the dot product of the first original vector and the cross product and the second original vector and the cross product. So I'm just going to do that for fun. Let's see what happens. How do you do a dot product again? First times first, second times second, third times third, and add them up. Okay, so what do we get? We get 5 minus 20 plus 15. What's that equal? Okay, here I get negative 10, and 20. What's that equal? What's it mean when the dot product equals 0? They're orthogonal, they're perpendicular, they're orthogonal. So look what happened, kids. I took 2 random generic vectors, just made up. We did their cross product. And this new vector that we got turned out to be perpendicular to both of the originals. Isn't that pretty amazing? So if you need a vector perpendicular to another vector, you need to do a cross product. Because the cross product will always be perpendicular to the originals. That's pretty amazing. Okay. All right, I have one more thing to do, and then we'll be done with the new stuff. Let's suppose, well, let's do this. Does anybody know what this equation represents? Like, if I wrote y equals 2x minus 7, you would all say, oh, that's a line. Do you know what this is? A line in 3 dimensions will look like this, Tom. It will look like the parametric equations. This was the parametric equations of a line. This is a line. So if you want a line, that's what you have. That's not a line. That's a plane. That's like the equation of the ceiling. That's a plane. How do we draw that? Well, first of all, we have to get ourselves comfortable with the coordinate plane in 3 dimensions. The easiest way, I think, for you to get a grip on this is to take your regular XY coordinate plane. Here it is. My regular XY coordinate plane. And jab your pencil right down through the origin. That's your z-axis. So now you have your x-axis, your y-axis, and your z-axis. So now you can, this is a good visual. When I put it on the blackboard, because this is 2-dimensional, I have to flatten it. This is actually a right angle here. This is the XY coordinate plane, and this is my pencil sticking down through it. Can you kind of see that? Now what I have drawn are the positive axes. So the negative one extends back here, and here, and here. So there's your axis system. If we want to graph this plane like a line, it's impossible to graph the whole thing because it goes on forever and ever. So we're just going to graph a piece of it. To graph it, let's let y and z both be 0, and note that the x-intercept is 3. If we let y and z both be 0, so we're on the x-axis, then x has to be 3. Does everybody see that? Now what's my y-intercept?
2.
Let everything be 0 except y, and y turns out to be 2, right? How about z?
6.
So far so good, kids, plotting the intercepts? That's easy. Connect them. What shape do I get if I connect those 3 dots? A triangle?
Yeah.
A triangle is one way of drawing a plane. That's a picture of the plane. A piece of the plane, anyway. Logan?
First y, you just take the 6 on the other side.
No. You let x and y be 0.
Yeah.
So what does that say? If x and y are both 0, these are like gone. What does that equation say?
Okay, yeah. I got you.
Okay? Tonight you're going to practice all the problems that we just did. except the cross product is not in the book at this point. So everything else you're going to practice tonight, and tomorrow we're going to have a little quiz over just this stuff, the three-dimensional stuff, to make sure you got it under control. Okay? Now, what I would like to do, did anybody have an issue from last night? Any issue in last night's homework, which was the rotation work, remember? Quick review. How do you tell what kind of curve you've got if you've got an XY term in the equation? You use the discriminant. What's the discriminant again? B squared minus 4AC. And what are the rules about the discriminant?
Negative is an ellipse.
If the discriminant comes out to be negative, you have an ellipse. Positive, it's a hyperbola, and 0 is a parabola. Okay, good. Would you get out your packet? And let's see, looks like it's the 4th page maybe. It says Precal A, quiz 8-1, go 5 win. Does anybody feel confident in coming up maybe and putting number 1 on the board here? And then somebody else coming over here and putting number 2 on the board? Anybody feel confident doing that while the rest of us do it at our seats? You got it? You're awesome. Which one are you doing?
Harry and I are team on number 1.
Number 1. Anybody feel okay about number 2 if I help?
We can just do them both, you know, because we're just going above and beyond for you, Miss Ford.
Well, thank you, Harry. And everybody else is doing it at your seats? Guaranteed test questions. Help each other if you're stuck. But we need to be able to do these pretty efficiently.
Oh, I think this is no. I think this is the. I think it's the roots. Oh, we're doing two.
Okay, guys, what do you think about the first one? Did you okay? I think they did great.
Honestly, Miss Ford, I don't ever know how to do number 2.
I'll help you.
I don't know.
I think Brian's got a good start. Ben, that's got a good start. Seven is a negative 16. Yep, so there's your equation. Let's sketch it. Yeah, let's sketch it. So where's your vertex?
Negative 3, 2.
Watch it.
Is that one the wise?
Okay, Harry almost, not quite, but almost made a pretty significant mistake that a lot of people make. He looked at his equation, step aside boys so they can see, which is correct. The circled thing is absolutely correct. Harry looked at that and said, my vertex is at negative 3, 2. Now that's easy to do, but you see why it's wrong? It has to be X and then Y. That could be very bad. Good catch. Okay, so where's our vertex? Is it 2, negative 3? Okay. And then which way do we open? Left. Very good. You open left. You guys know what you're doing. You're doing great. You open left.
I like for focus on this one, what is it? What do I do?
Who can help him find the distance from the vertex to the focus?
Come up here.
Hey, no, this isn't a sorority meeting. What
I
are you guys
just-
talking about?
Did this on my phone. I did all that all day on this for you to be proud of me.
Come up on the board, help us out.
How do we find the distance from the vertex to the focus?
Four
4p.
Okay, so negative 6.
4p equals 16, so p equals p equals 4. So you're gonna back up 4.
Yeah, but he won't say it out loud.
Because p is how far you.
So you got this, like over here.
Okay, I think it's
Starting your
negative
vertex.
4 this way, right?
Start at your vertex and back up 4.
I know what I'm doing.
But I got mine.
Yeah.
Financial aid.
D is on reactor.
Do you want me to leave it?
And then AS is, I mean, I actually, I just. Oh, okay, that's why I said that, I was somehow like half of it. I think that's FW is.
Focal width, length of the one spectrum.
Would you actually?
Oh, yeah, we're backwards.
Well, actually, you do, but you know the length of the long spectrum.
Oh, that about her ring.
So that's
I'm gonna ask him though, if he did.
The length of the travel.
Yeah, through the focus. The seg, draw the segment through the focus. That's amazing. Draw the segment right here. that that's your focal width for that system. So to get those points, which is your next step.
Eight down.
-2 up is 5. So -2, 5. -2,
Okay, let's see how they did. I think they did great. Who has a question about that? Guaranteed test question, folks. You have got to be able to do this all by yourself. Yes.
I thought focal width is like half of what is in the equation? Like 16, I thought it was 8.
No. Now what 8 is the distance, okay, your focus is in the, right, is the midpoint of your lattice rectum, right? So the 8 is how far up and down you go to get those points.
So the number that's in the equation is what?
Is the length of the lattice rectum, yep, yep.
Wait, you know what this option is? And it opens left because the 16 is in.
And it's y squared.
Pretty simple. Very simple. If it's square on the
Any
y,
other question
that means
about
it's going to go
this?
left or right.
Turn it over.
The other way.
And look what we've got on the back.
Sure, positive
But
this
I'm just saying, okay, I understand that, but that's how it is. So just remember.
Positive
Yes,
is that
but
one.
I'm saying, wasn't that
Positive
a
is
question?
this way.
I think
All right, what is equation, we're on the back side now. What is equation number 1? It's a parabola. They just did a parabola. We just talked about that. We'll all practice. So who'll come up and do this new parabola here?
we've already had the whole
Someone
thing.
from this side of the room?
Do the video game, kid.
If I help? Katie Swanton, just because you avoid eye contact is not me. Come on, run up.
Oh, no.
And I bet you don't do much. Yeah, Grace can come out, absolutely. So just erase the circle over there.
I got it.
Okay. What are the rest of us supposed to be doing?
Doing it on our own.
Doing it on your own, very good.
I don't even know how to get it set up for the right place.
Honestly, you're lucky we didn't just.
Harry, I should not hear your voice unless you are talking about
Well, I
parabolas.
don't have a pencil. That's why I was so eager to go up there.
Harry,
Miss Ford.
you need to get your act together.
I do.
Green.
First, what's the eccentricity of a parabola? Eccentricity of a parabola is 1. Very good. What's the eccentricity of a circle?
0.
Always, always, always. Those two never change. So if you need the eccentricity of a circle, you will say 0. If you need the eccentricity of a parabola, you will say 1.
Why would it open left? Why would it open left?
It's a flim plane.
Yeah, I think there's, it's Y positive, it's open left or right.
If it's Y positive, it opens right.
Well, she reads the other. Why the H? You know what I'm saying?
Yeah, you're right.
I don't know, I she like this,
No, it stays at -1.
Because you're just going straight forward, up or down. So you're staying at -1.
And then we have to move that to the halves to move the direction. That's -1.
I don't know, it's called out. I think years attitude, which is.
Yeah, it's just kind of a terrible attitude.
Yeah, you do.
Uncomfortable.
That's not
And
polite.
the directrix key, you got the right idea,
Yeah.
it's a line.
They opened it up to the right.
Before spring break, and I just, you know.
They did.
Mrs. Ford, did I open up the problem wrong now?
No, so you had a y squared and you had a negative.
Oh, it doesn't matter where the negative's at.
Yeah, can we review which way it opens?
If it's positive, it goes right. If it's negative, it goes left. And it's the number on the outside of each one.
I'm sorry.
It doesn't matter where the numbers are.
Yeah, Ben lied to all.
No.
You told us a whole different lesson.
No. Ben, I told him from my heart.
No, you lied.
That didn't sound right.
Okay, the girl's parabola was a y squared positive, so it opens to the right. Y squareds are sideways. Positives are right, negatives are left. X squareds are up and down. Positive is up, negative is down.
Thank you.
Okay, now, the girls weren't asked for everything that we normally are asked for. They answered what they were asked, that's perfect. Anybody have an issue with what they did? When you get these fractions, like P was 3/2, if you're comfortable with the fractions, use the fractions. If you want to think of them as decimals, use decimals, it doesn't matter.
So you just move over
1.5.
from the point of
a great day.
From your vortex to find your focus.
Yeah.
Okay?
Here's a better, here's a
All just tomorrow.
All right, we'll review tomorrow and Thursday. But tomorrow we are going to have a little 3D quiz. Stephen, can you turn that off, or John or somebody?
John's got
Have
that.
a
Tell me
little
if I get
3D
it.
quiz.
I already command you right